Yashar Behzadi, CEO and founder at Synthesis AI. Welcome to the Data Exchange podcast.
Well, thanks for having me. Excited to be here.
So this is a conversation about synthetic data broadly, but I think in your case, specifically for computer vision, which is great.
That's right.
So first of all, Yashar, for people who don't follow synthetic data, I think most people will probably know that there's a lot of new synthetic data startups. So how does someone evaluate synthetic data? So I guess it's kind of like regular data, except for one thing, right? So in terms of regular data, if you're trying to label a data set, assuming the labels are okay, then you assume that's ground truth, right?
Correct.
So, but with synthetic data, so how do
Yeah, let me take you through a little bit of our journey of how we got here, and I think it's a typical journey for anybody that plays with data. I think if you ask anybody from a ML developer, through the stack, they'll tell you the same thing: data sucks. Getting data, labeling data, preparing data, right? So we started Synthesis AI and are going to lean into synthetic data to really solve the data problem for computer vision, right? And I think, and if you look at the broader view of kind of computer vision, the whole life cycle of how you develop a product, I think synthetic data actually enables you to do things in a very different way, and it changed the paradigm and actually solve a lot of fundamental issues. So in computer vision, you oftentimes build hardware, right, to first acquire data. So if you think autonomous vehicle, if you're building fleets of vehicles with hundreds of millions of dollars of expense to go out in the world to then capture data for prolonged periods of time, to then have humans label it, to then train your system, to at the end of that process answer the question of what your system can even do, right? Now, if you contrast that to any other engineering discipline, it's inverted. So the way you build planes or do mechanical design or chip design is you have tools that allow you to replicate your system with enough fidelity that you can leverage them to create your system, right? So CAD tools, design tools, signal processing tools as well. So we feel...
But they had to get to that point, right?
Oh, that's the journey that we're on now, right? So, so if you look at the tools that have kind of really enabled synthetic data and kind of why there's so much interest in it, it's really two technologies, right? The first one I think is one that most people are really familiar with because it's the visual effects technology, right? If you look at how good movies have gone in terms of replicating photorealism, it's quite amazing. And I think the real driver there is that it's commoditized, it's more accessible. It's things like Unreal and Unity and all these other tools are now in the hands of just anybody who wants them. Right, so there's that force, and then there's a generative AI side, right? Things like GANs and various autoencoders and diffusion models and things that have just exponentially increased capability. So that combination allows you to, for the first time, at scale with high fidelity, replicate the physics of objects and light and interactions. And if you can do that, then why can't you train computer vision models completely virtually, right? That's our thesis.
But at this point. It's probably more of a augmentation.
Yeah, I'll take you through
than an outright replacement, right? So
I'll take it. Yeah.
In other words, I'm not gonna train a model, an object recognition model for an autonomous vehicle solely on synthetic data, right?
Maybe not today, but you will soon. You will soon. Yeah. So the way we're seeing it is definitely augmentation.
Give us a prediction of the timeline there.
I think within 3 years, and you already have startups today doing this. So I think if you look at it today, right, and when we started Synthesis...
Wait, before you proceed, so do you think, though, the regulators will let them drive purely on synthetic data on public roads?
I'll take you through, I think, how I see that paradigm I described initially being changed, right, with synthetic data, right? So we have these great technologies that are allowing us to really replicate things with high fidelity, and the nice kind of a value add for these tools is the diversity, right? You can explicitly model diversity, so you can deal with bias and edge cases and all these different things. And of course, the labels, right? The labels that you can extract from these mechanisms, because you're creating the 3D world, are really quite differentiated from what humans can provide, right? So you need depth maps, surface normals, material properties, 3D landmarks. So, we do a lot of work personally in kind of human-centered systems, and we're able to extract, thousands of 3D points on the face, right, which humans can't provide. So you get this really interesting combination of scalability, diversity, and never before available labels to help you build systems. Okay, so that's the value. But it's being used in kind of three discrete ways. I think the most obvious place that people start is augmentation, right? I need certain edge cases, or I don't have certain demographics that I'm interested in, and so I'm going to augment out.
Or QA testing, right?
Yeah, so you're kind of augmenting your data sets, you're supplementing it with synthetic data. And there's a number of great techniques that have emerged to be able to mix real and synthetic, because there is this domain gap, right? Synthetic isn't real. As good as it looks, there are statistical differences. So things like domain adaptation, refinement approaches, label adaptation, we can dive into those different approaches. But now we're getting to a place that people are really starting to understand how to mix the two and use them together to kind of advance and ultimately build better models, which is what you care about. So that's the augmentation piece. There's this other area in which you're building models that you can't build in any other way. And this is really has to do with the availability of these additional labels, right? Again, giving the example of kind of some of the facial work that we've done and others are doing in the space, is if you need thousands of points on the face to realistically capture someone, recreate them, and track their subtleties, humans can't provide that data. So you need a different way of training those systems and testing those systems and really hardening those systems, right? So synthetic data is a great mechanism to do that.
So what's an example use case for that? The thousands
yeah, avatars. So for kind of metaverse type applications, what people are really investing in now are these like fundamental models that will enable a whole bunch of new kind of experiences. One of those is going to be being able to replicate an individual with high fidelity and capture their movements and expressions and all the subtleties in this digital world, right? But to do that, you need really good landmark estimation approaches and really good reconstruction approaches. And it's impossible to use real data assets to do that because of the granularity and the consistency of the labels that you need. So we've shown this work. Microsoft has published on this as well as greater kind of additional validation that actually using synthetic data counterintuitively leads to better models than if you use real data. Right, so that's another great kind of area of utilization where you can't obtain the labels for humans. And then the other area where I think it's further downstream, but I think is going to have a significant impact, is this concept of virtual prototyping. Right, we have customers today, and others are doing the same thing. Is you're trying to use a virtual space to answer fundamental questions. I'll give you one example. So we had a major,
basically like a digital twin.
Exactly. So we have a major car company that we work with, and they were doing driver monitoring. They wanted to understand if people are falling asleep or engaging kind of in certain behavior. And the first question they had was, where do we put the camera? Right, which seems like a super simple question to answer, but in the context of AI, it means get a bunch of cars, get a bunch of camera systems installed in those cars, get waivers from a bunch of people, and drive around for months and hopefully capture those elements. Right, that's a traditional computer vision, AI-driven, real human data approach. Right, but with synthetic data, you say, okay, well, let's put 1,000 people doing 1,000 different things in the car, simultaneously image from all these different configurations that you're interested in. So you can do 20 different configurations, right, and do the trade-off study, going from potentially months or years of work to days and weeks of work to answer those fundamental questions, right? So we're seeing increasing use of synthetic data for this kind of virtual prototyping and building your systems ahead of even hardware development.
So going back to my question about regulatory challenges. So in that example you just shared, I mean, I can see where a car maker can use that to really accelerate R&D, but at the end they may have to actually put the camera in the car to satisfy regulators, right?
That's right. I mean, I think you're gonna, until there's enough confidence there. I mean, we've seen this in every engineering discipline, right? There's a transition to these digital tools for design. But eventually you get people have so much confidence in them that become that the need to test things in the real world becomes less and less. So of course, at some point you have to build the thing and see if it really works. But it's really an augmentation on how you get to market faster and how you make smarter decisions, right? And we're seeing startups do things very differently. Like in robotics is a good example of this, right? In the robotics world, oftentimes you build a piece of hardware and you train it to do a specific task, right? Now people are saying, okay, let's invert that and say, let's pick the task and then do a whole bunch of virtual iterations of different robots to figure out which robot is the best to do that task, right? So you're using this kind of virtual space to actually do and select the best optimal system for that particular use case, right? Which is really going to speed up and I think increase kind of capabilities across the board.
So I actually read a couple of interesting blog posts on your company blog about the recent CVPR conference, right? So what struck me is that I guess one question to you, Yashar, is what aspects of synthetic data are basically commoditized because in those posts, those are really bleeding edge kind of ways of thinking about synthetic data and the next generation of generative models and diffusion models, right? So what aspects of synthetic data generation are super accessible now to regular?
It's a great question, and I think one thing that we've been really supportive of, right, is just evangelizing synthetic data and really making sure more people have access. I mean, democratizing access is one of our core values. We've written the book, we've launched Open Synthetics, to help kind of build this community, and it's great to see that these tools are becoming much more accessible. Now, using synthetic data in a particular context is getting easier and easier as the tool chain. If you think about game engines and these other things that you have access to, the availability of certain assets, it becomes easier and easier to create the assets for a particular scenario to train a system. Where I think it's very hard is to get to production level, right? So, it's easy enough to get a couple of people, in our case, right, to get a couple of people and create some synthetic data and train. But when you're kind of creating a production level system, you need 100,000 people, you need millions of data points, right? That's very hard to do because you need to create this really rich set of assets that speak to the diversity that you need for that particular use case. You need to have really robust procedural logic, essentially, to be able to create the scenes and manage all the different complexities related to that. And then you need the infrastructure to be able to render out at high quality millions of images and do this on a fast enough basis to allow for iteration. So it's quite easy to get started with synthetic data. It's quite hard to get the production level data for real systems, right? And that's what we're seeing right now. The whole proliferation of smaller companies, like that are starting to get in, or people within bigger companies that are building these systems, but they all kind of hit a wall when they get to, okay, I think it works, but now I need 1 million people to do my, my system for real scale production. So then that's when people turn to, more mature providers like ourselves.
So is this space of synthetic data basically the basic ways of generating synthetic data? Do they tend to be all open source, and it's just the scaling and productionizing that needs companies? So in other words, are there like a bunch of free tools like a TensorFlow, PyTorch for synthetic data that people use?
Yeah, it's emerging. I mean, there's definitely the game engines that people kind of build on top of. Again, it's hard to get the assets oftentimes at the scale that you need. I mean, for us, we do a lot of human-centered stuff. So you need, humans are diverse, right? You need to capture, sexes and genders and, different demographics and ethnicities and ages and BMIs, right?
So these libraries don't have parameters for you?
No, not nearly as robust as you would think. So, we've invested a lot in our pipeline to do that at scale. We have, 100,000 people or whatever in our system, and we can really fine tune, modify them. So that's what I mean. Like, to get to production scale is actually pretty hard. To try things out to show that it works is quite easy. And use cases are different. Certain use cases are going to be easier to do. Human stuff is hard because humans are hard to create digital assets around. You see a lot of folks doing like CPG, synthetic data for CPG or object detection. It's easier, right? Because those objects are really well described. A Coke can or cereal box, is pretty well described. There's, assets out there. There's easy ways to make those assets. But, creating a person doing something very complicated or interacting with objects is very hard. So there's going to be this, I think, spectrum of types of use cases. But with all that said, it's getting easier and easier, and this ecosystem is growing, both for assets and procedural logic and these kind of tools that are going to enable this. So we're very excited about where it's headed.
So what is the state of the art for synthetic video? So in other words, if I need models for video, not still images, are there synthetic data tools?
Yeah, so I'll take you through two different approaches that people are kind of using. So we tend to use kind of a hybrid approach, which I'll describe a little bit, and then I'll describe some of the other approaches as well. So, a third of our team is CGI experts, right? Pixar, Disney, ILM, folks from this kind of pedigree. And a third of our team are software engineers trying to put systems together. And a third of our team are ML guys who understand generative models. So that unique combination allows us to leverage the right technology at the right point, right? To create ultimately a pipeline that you can create massive amounts of assets and then have pixel level control using traditional CG pipelines to create the end of assets, right? And once you're in that framework of that 3D world, creating stills or videos is the same, right? You can have sequences and animations and do everything, right? And the key and the reason we lean into that type of pipeline is because you need the labels. You need all those really fine-grained elements. Now, there's another place that people are really leading into and starting, which is pure generative models, right? You look at the amazingness of DALL-E 2 and stuff that Google is doing and others in space. Those are really, really good at creating really complex compositions that, right, are kind of contextually driven by the prompts, which is great for content generation. It's not so great for training AI models because you don't have the labels. You don't have the segmentation maps. You don't have the 3D elements. You don't have the depth maps, right? So that's limiting in the way you kind of ultimately kind of potentially leverage that technology, right? Over time, it might get better, and there might be some ways of extracting those labels, but they're kind of different technologies for kind of different kind of use cases, in my opinion.
So what verticals are the most avid consumers of synthetic data right now?
Yeah, great question. So I think AV, autonomous vehicles, right, was really the first place that people leaned into it because there's a huge amount of investment happening, right? So it's really partly driven by the investment cycles and the innovation drivers there. People are spending hundreds of millions of dollars on labeling data for autonomous vehicles. So people started really saying, okay, there's got to be a better way to do this. And simulation.
There's massive companies like Scale, right? So.
Yeah, so I mean, in the AV space, it's really there's a couple startups, Applied Intuition, Parallel Domain, a bunch of others in that space. They're trying to service, synthetic data for AV. A lot of the big AV companies have their own simulation platforms. So Waymo, Cruise, Zeus, all these guys have their own significant investment within the simulation, and it makes sense because it's so expensive to obtain the data, and you can't obtain the edge cases, and your hardware is always changing, and you don't want to always go out and collect new data. So that's been a huge driver, I think, and validator essentially of synthetic data. The next big segment is robotics. And again, big drivers of cost. Like to build a robot and train it in real time is incredibly expensive. Which you do it virtually, opens up a whole bunch of different kind of capabilities.
So are there specific segments in robotics? Are these warehouse robots or?
Yeah, I mean it's probably bifurcated in two areas. There's kind of pick and place robotic arm systems, right? There's three. There's visual QA systems, and then the third is like logistic robots, right? They're actually navigating and moving things within an environment. All three have used synthetic data pretty heavily, which makes sense. Another category is kind of geospatial. You're seeing some companies do some interesting work in the geospatial space with synthetic data. We work in human-centered systems, right? So ID verification.
Elaborate a little more on the geospatial. What do you mean there?
Yeah, so being able to create essentially virtual cities, right? Using kind of input geospatial data, and then allowing people to extract images from that. So if you're doing identification of certain types of vehicles or certain types of buildings or certain types of scenarios, they're oftentimes very hard to obtain. But if you can simulate it from your product system, it's a great way of augmenting your data sets, right? So it's a computer vision problem for geospatial, but using synthetic data, obviously, to inform that. And then the area we focus on, and a number of other companies as well, is human-centered systems, where it's oftentimes very hard to get the data because of privacy concerns. There's issues with bias, right? And then there's technical issues that I described. Like you can't get certain labels very easily, right? So it leads you toward using synthetic data. So there's a lot of use cases, obviously the long spectrum, long tail of computer vision.
So in the human-centered systems domain, so what are some examples there?
Yeah, I think the biggest consumer is AR, VR, metaverse type applications.
Okay.
Right, where I kind of describe some of the use cases. Driver monitoring is another area which has had some interest recently. There's some emerging applications which are pretty exciting. AI fitness, where you're trying to track, pose of the body in a fine-grained way. Virtual try-on, where you're trying to estimate the body and how clothes may sit on that body. Generative media. There's ID verification. So handset manufacturers and payment gateways and others are trying to use biometrics, and that there's kind of use of synthetic data in that context. So there's a number of really interesting areas to invest in synthetic data.
So in language, right? So I actually work mostly in NLP and text. So there's all these large language models, and some people call them foundation models. I don't like that term, but whatever. But anyway, so the situation there is you have many pre-trained models that you can take off the shelf. They work surprisingly well, but the reality is you probably need to tune them for your specific application or domain. But the point is that there's a lot of pre-trained models that you can start with. So in the computer vision space, there's also pre-trained models these days, right? So as far as synthetic data, then is there do companies with access to massive amounts of data and massive amounts of compute, do they have distinct advantage? You know how in some of these areas the models are so big, it's just a handful of groups who are training them, right? So
sure, yeah, no, there's always a little unfair advantage with whoever has the resources, obviously, and the data. But I actually feel like synthetic data is an equalizer, right? Because people have gone out and built these huge data moats, right? And in the human centered stuff especially, like if you can,
but the amount of compute is within reach.
Within reach. And I think there's obviously, and you've talked about this on your podcast as well, it's just, there's a big transition, right? Moving from model-centric to data-centric AI, right? And people have these mountains of data, but if 90% of it is the same and not actually providing any new capabilities, then that only means you have 10% that's valuable, right? So I think people are starting to really engineer their data, and using synthetic data allows you to kind of explicitly define your distributions, right? To serve, exactly what kind of edge case, kind of cases that you want to service in kind of the model performance areas that you want. So you're essentially explicitly kind of programming your neural net through the input of the data distributions to match an output that you're excited about, right? So you can get away with a lot less data, a lot less compute, smaller models. We're early in that. We're totally early in that. So I'm not going to claim that people have figured it out, but the trend line is clear.
And many of the models seem to be shared openly, right? So are there a lot of secret proprietary synthetic data models?
Yeah, no, I mean, so, the synthetic data is a means to a model, right? So a lot of the same model architectures are used for synthetic data and real data.
It's generative and diffusion models, right?
Yeah, so that's a part of how you create synthetic data, right? And then each use case is slightly different, right, in terms of what the model you're trying to build. And there's no model is perfect, so there's always edge cases that you can service, and you're going to use data to continue to kind of push forward those capabilities. There's not going to be a slowdown in data, right?
But people are always going to want. I imagine, Yashar, too, it's as you say, right? So some basic models might be out there in the open source or published, but it's like anything else in AI and machine learning, it's a pipeline. So you may start with that model in that paper, but then to make it work, you got to piece together a few things. Right?
Absolutely. And I guess the point I'm trying to make around the data-centric approach is that the model may be stable, but if you can change the input data, then the capabilities are very different, right? So people are starting to really focus on, what does that data distribution look like? What's the right way of creating that distribution for an endpoint that I'm interested in? So even though the models are matured and potentially stabilized, the capabilities are still going to be augmented and very different based on the data assets that you have and have access to, right?
So what about what are the implications as far as responsible AI?
For us and others in the space, synthetic data is a means to really address some key issues, right? I think when you're talking about human-centered systems, the first issue is privacy, and the second issue is bias, right? And privacy, obviously, if it's synthetic, it's easy to see how that kind of gets satisfied. Bias has to do with class imbalance in your input data, right? But if you're explicitly defining those distributions, then you're by design ensuring there's less bias. Right. And the key for those systems is you have to have enough diversity in the asset base to capture, the overall distribution you're interested in. So we've been very focused on, okay, if we have 100,000 IDs in our system, right? And we've created those IDs in various different ways we can talk about. But it's balanced across ethnicity and age and BMI and gender. Like these things are very important elements to capture. And it's a continuous process. We're going to have to continue to invest in hyper diversity, right? Because if you get, not all people are the same, and there's a lot of diversity, and as we're trying to build these systems to work for billions of people potentially in this new metaverse construct, we need to be very conscious of making sure these systems are unbiased and work universally, right? So synthetic data is a great means to that, and it's a great democratizing force because now everybody has access, right? Versus everybody has to build that proprietary data set themselves.
As far as traditional software engineering, I mean, it could help you make your systems more safe and reliable, right? Because as far as QA and testing. But on the other hand, though, Yashar, there's the whole notion of deep fakes and all of these things. So as the synthetic generation models become more and more accessible, there's more and more potential misuses of it too, right? So
yeah, no, it's always double-edged with any type of technology innovation. But I don't think it's going to be any different than what people did with any technology, right? I mean, when email came out, there was email spam campaigns, right? I mean, just any new technology is going to be ripe for people to try to take advantage of it in different ways and do whatever they need to do. But that just shouldn't gate how we think about the technology. It should be, really,
Is there so what is so there's no way for the synthetic generation tools are they light years ahead of the synthetic detection tools?
It's an arms race in some ways, right? Like, and even if you think of like these adversarial networks that people use to create synthetic data, I mean, it's there's a detector and a generator, right? And when one gets better, the other one gets better, and there's always going to be that kind of capability and around that. So I think we'll continue to get better at identifying it, and people who are malicious and have bad intent will continue to figure out ways to get around that. But that's still going to be a very small percentage, I think, of things in the space, and the net benefit will far outweigh. I think.
But here's some anecdotal evidence. I think to support the case where that the generators are more advanced than the detectors. I don't hear many synthetic detection startups.
Well, I don't think it's really that big of a problem. I think there's a lot of great. I mean, it's fun to talk about. Obviously, it's something that be thoughtful about as these things emerge. But I don't think it's a meaningful problem, right, in the space. And again, any new technology always has folks who will misuse it. But I don't think that should gate us from continuing to innovate in a responsible way.
So in many ways, I think synthetic data, without synthetic data, getting to the metaverse will be impossible, right? Just basically just building the equipment, making sure that equipment works, and all of that.
Yeah, every major AR company has synthetic data backbone to help supply and to create those systems. And it's beyond the people, right? If you're trying to understand the space, you're trying to understand the light environment, you're trying to understand the materials, you're trying to understand, let's say, the 3D kind of interactions between things, you can't get that data from humans. So you have to do something else. And that's why it's so important in those pipelines and enablement. So
in your case, so you're only interested in visual data.
Correct.
So does that include like medical images?
I think there are going to be really interesting use cases for synthetic data in medicine. It's more complicated. It's not what we're focusing, but I'm sure there probably are startups out there looking at, how to provide, synthetic medical images. Anywhere, I think, where data is really hard to get, obviously, and you need certain labels that are hard to obtain, and synthetic data makes sense. There are easier and harder things to generate. I described kind of the CPG goods kind of thing, like, cereal box. Very easy to kind of generate that. Humans are hard. Well, if you're going to do like a longer, whatever you need to do for a medical use case, it's more difficult, right? So there's going to be a spectrum, but the technology is not bound, right? A use case in that regard.
So what will determine progress in the space?
I think ultimately it's deployed models, right? We want to see more models deployed using synthetic data, right? And there are a number of companies out there that use synthetic data pretty routinely in their pipelines. Which is great. Some of them are not as open as others, to talk about that. But it's been great to see companies like Microsoft, for instance, publishing, openly around. Okay, we have a digital humans program, and we train these types of systems using our synthetic data, and it works better than real data. That's a huge validator for the space, which is wonderful. The other thing I think is going to be really helpful is we're trying along with other collaborators to push open synthetics out into the community. So this is a vendor-neutral open community for synthetic data research. There's a number of data sets on there, and papers and code. And I think the more people kind of lean into that kind of community, the better we all are, because the proof points are going to be in the wild, and that's going to help everybody.
So what research breakthroughs need to happen?
Oh yeah, great question.
In your mind?
Yeah, I think it's there's a number of places, right? And people are actively researching this. I mean, one, let's start at the end, I guess, which is the gap between real and synthetic, right? There's this domain gap problem. And again, as beautiful as these images look, they're not real data, right? So there's always going to be some difference. So increasing kind of innovation around.
But Yashar, the gap doesn't is already closed in certain areas, right? Like generating fake faces.
It's getting. There's always work to be done in making it easier to train with synthetic data, right? And there's different approaches that work in different use cases. In our experience, there's refinement approaches, domain adaptation, late adaptation, mixed training approaches, pre-training approaches. It's a little bit of trial and error for each kind of use case to figure out what combination of those tools and kind of techniques works best. You can imagine in a future state that and kind of an auto ML kind of type framework is wrapped around that, and an auto data framework is wrapped around that to make it just much easier to create the right data.
Because basically, in many areas, the domain experts are not programmers. You have to give them tools so that they can work with the data, use their expertise, but not have to code, right?
Yeah, I think that's here. Domain, I'm referring to synthetic versus real, right? The kind of the data domains. Again, but I think that the key there is that
no. But I mean, when someone, when you want to train a model in a specific area, let's say specific area of medicine,
sure.
the expertise is so specific. There's only a handful of people, and they're not programmers, so you need to give them tools in order to help.
Oh yeah, no, I totally appreciate that, but I think that's a broader ML AI issue that I think it needs to be solved, right? And there's obviously tools and things being built around that. But synthetic data specifically, I think the key is what data should you build, right? And right now it's mainly driven by insights from the customer. Like I know I'm missing this type of data or whatever, but you can imagine automating that. If you have a corpus of real data or you have an established model, being able to infer what the limitations are.
I have a tool for you.
Okay.
Built by my friends. They just released it. It's called FastDupe.
Okay.
So it's written in C++, and basically, they can go through large collections of images really quickly and tell you duplicates, mislabeled data, anomalies, and this and that. So they've actually done it for a lot of the public computer vision data sets. So they found so many mislabeled and duplicate data, for example, in ImageNet and a bunch of these places.
Yeah, so tools like that, I think, will continue to evolve. And I think that where it gets really interesting is when they can basically point out areas in which you're missing data, right? Or you're limited in data, right? So I think catching errors and stuff, it's very valuable.
Oh, yeah.
So to be able to say there are these biases in your data set, right? So that's step one. Step two then is generating that data. Right. And then step three is training in a mixed sense with real data. Like all of that's going to get automated over time, and it's going to be, I think, exciting and make synthetic data much more accessible. The other key innovation is how you create assets, right? Or how you actually generate the synthetic data. And there's a lot of stuff happening on 2D to 3D, right? A kind of conversion, things like NeRFs and diffusion models, and be able to create, robust content. And so there's a lot happening on the generation side, and there's a lot going to happen on the actual mixed training side.
So you mean if I have a lot of great 2D images, but I need 3D images, 3D images, you want tools to go from 2D to 3D, and the 3D to be so good that it's indistinguishable from.
Yeah, no, absolutely. And then you can imagine even taking it a step further is once you parse everything and you have 3D models of everything in that scene, you can manipulate the scene, right? You can change the scene in 3D and re-render it, right? So then now you have this ability to, just create vast amounts of really complex data and mimic the kind of procedural or kind of the logic within the scene composition to kind of service a use case. So those are all early stages, but it definitely, I think
now I see why you have so many CGI people in it. All right.
You need both,
but don't you think these ultimately all these tools need some sort of UX so that people can interact with the data without having to go to command line all the time, right?
Yeah, absolutely.
Yeah.
Things have to get easier.
Yeah. And so do you follow synthetic data in non-visual domains?
I'm familiar, right? I'm kind of more structured side as well.
Yeah. So which of these areas are as promising as computer vision in your mind?
Yeah, well, there's a lot of utilization of synthetic data and structured data, but a totally different use case, right? It's kind of all under the umbrella of synthetic data. But on the structured side, it's usually used for data obfuscation, right? You want to preserve privacy,
Right.
enable kind of a replication of a data set to be used in a training environment or with an external partner, right? So there are a number of tools and companies that have, that seem to be doing pretty well based on their financing to kind of service that use case, which is different than our use case, but that seems to be an interesting area. I think earlier is things like voice generation, right? And then voice with video, right? That's going to be kind of an interesting growth area as well. Time series, people are starting to do some stuff there. But so it'll work into every modality.
So actually going back, so you mentioned voice. So going back to video. Sure. So how good is synthetic video generation now?
I mean, we use traditional CG tools, right? So if you see something in the movies, that's reflective of what we're able to do with our stack and the other people can do with the stack. The difficulty again is getting the assets, getting the animations, getting the things that you want to produce, but the technology behind it to create really good.
Yeah, diversity. I mean, because video, I mean, images is one thing, but video having, there's so many things that can happen when you put in time, right?
Yeah, I'll give you a few examples. Yeah. Like there's a number of companies interested in AI fitness, right? So they want to be able to give you real-time feedback on your form and count reps and do these different things. Well, to do that robustly, obviously it's an animation sequence, right? And for any particular target exercise, what you need is a bunch of diversity around body type, a bunch of diversity around clothing, because that's a confound, camera angle variations, right? Environmental lighting variations, right? And then form variations, right? So there's a ton of diversity and dimensions to manage there. And some of that you can do really robustly through kind of these procedural approaches. So for us, like if someone wants to analyze a push-up, we can take a single animation of a push-up, create variations of that, kind of by jittering certain elements of the animation in meaningful physiologic ways, map that to thousands of body types. And for each of those body types, do thousands of clothing options and then do thousands of viewpoints of cameras, right? So you can see how that extrapolation, can happen.
It's a lot
of data, but that's what you need to build production level robust, computer vision for these types of applications. And so you can see how difficult that would be in the real world, right, to get that type of variation. But the synthetic data, you hit a few buttons and you go.
I guess what you described there reminds me of all of the technology that has been invested into breaking down someone's golf swing. Right. So, and then you map that to all sorts of other movements, right?
Yeah. So, I mean, there's a huge, obviously, if you think about gaming and you think about visual effects industry and movies, right? Mocap, animations, like, that's bread and butter for a lot of folks, right? The key is once you capture a particular emotion is how do you actually extrapolate it, right, to thousands of body types? How do you then add the confounding elements as well, like clothing and angle and all these different elements, right? So all of those pieces need to be together to actually build a robust data set to service these applications. So
in closing, so when we talked about breakthroughs, so one area I was curious about is hardware. So do we need even better cameras, even higher res cameras to get to what you want to get to?
Good question. I think we're at a pretty good place today with kind of the capture technology. I think what you're seeing in the capture technology space is actually moving to simpler systems in some way, right? So you can go to a motion capture stage today for animation capture, right? And you can hundreds of cameras, all synchronized. It's like a really sophisticated setup. But what people are trying to actually do is say, okay, how can I take all that complexity and put it into a single camera in my phone? Right, and that's where AI is actually helping kind of bridge the capture. So people are trying to do motion capture, 3D reconstruction from single viewpoints or maybe two viewpoints. So there's a whole bunch of
because before you have to wear something, right?
Oh yeah. So exactly. But as you think about metaverse, you think about other applications that require understanding of human motion and body composition and stuff. You can't have people stepping into a light rig to do that. You have to get to easier acquisition, right? And the technology is getting better and better. The hardware is commoditizing, right? So you're getting, iPhone with, kind of time of flight systems in it and multi-camera systems, right? So it's moving the opposite direction in some ways. It's going from these really sophisticated camera systems to simpler camera systems that are AI enabled that get you to the same endpoint.
Depending on the use case, because I still would want LiDAR on the self-driving car.
I have no comment. I don't know. I'm not familiar enough with exactly what you need. But
and with that, thank you, Yashar.
Oh, absolutely. That was a pleasure.